In section 4.3, we're going to look at doing segment and angle proofs. So remember, in our two-column proofs, we talked about having our statements on one side and our reasons on the other side. So when we are looking for what some of those reasons are going to be, we are going to use a few of these right here. So this is our two-column. We have our statements and our reasons. Reasons on this side, and these are some of the examples we have. For both angles and segments, we could use the definition of congruence. So if we had something like AB equal to CD, and we wanted to say those were congruent, if we know they're equal, then they're congruent. That is a definition of congruence. Some of the reasons for our segments might be the definition of midpoint. So remember, if we have a segment here, there we go, a segment. Now my pen's working. And if they tell me that point M here is my midpoint, that means that our two sides, AM and BM, are equal, and we know that because it's a definition of midpoint. M in the middle means those two sides are the same. Then we have our segment addition postulate, so that's saying that we have one piece of a segment, like AM here. If we knew that AM was 3 and MB was 3, we know the whole thing would be 6 because that's our segment addition postulate. If we have two pieces, we can find the whole, or if we have the whole thing in one small piece, we can find the other missing piece. So those are some examples where we will use the segment addition postulate. Some of the reasons when we have angles are our definition of an angle bisector. Remember, an angle bisector is where we have an angle and our line that goes and cuts that angle in half. So that means this side is going to be the same as this side. That's our angle bisector. Similar to our segment addition postulate, we have our angle addition postulate. So if we have this angle right here is 60, and this angle right here is 60, we can add those up and say that our whole angle is 120. Then we have the definition of complementary angles, and remember, complementary means they add up to 90 degrees, and supplementary means they add up to 180 degrees. Okay? So our first example asks us to prove the following. If we have that AC equals DF and AB equals DE, then BC equals EF. So this first part, the if, the hypothesis, is our given information. So it's saying if this is true. So I'm going to write given over here just so we can see it clearly. AC equals DF and AB equals DE. Okay, so if we know that's our given information, we need to prove that BC equals EF. Okay, so let's look over here. I'm going to write our two-column proof on this set of lines. I'm going to put my statements on the left and my reasons on the right. So then the first thing I need to do is write my given information. So here, first line, I'm going to write AC equals DF, and that is given. Our second piece of given information, AB equals DE, and that is given as well. Then I need to look and see what I've got. So if AC right here, this whole line is equal to this whole line, and we have AB, this piece is equal to this piece. We want to prove that these two pieces right here are the same. So to do that, we are going to take our AC right here. We know that AC is equal to AB plus CD. Sorry, AB plus BC. And that is because of our segment addition postulate. I'm not going to write out the whole thing, but segment addition postulate. And we also know from that segment addition postulate that DF is equal to DE plus EF. Now when we substitute, we take this equation and plug it in for AC, and we take this equation and plug it in for DF. We are left with AB plus BC equals DE plus EF. And we got that from substitution. Okay, we're getting closer. We are trying to get here that BC equals EF. So we want to get rid of that AB and DE. Again, if we know that our AB and our DE are the same, I can take my AB and plug it in for this DE so we have it on the same side. We'll have AB plus BC equals AB plus EF. And again, for E, I used my substitution property again. Okay, I'm close. Now I just have to get rid of that AB on both sides. So if I have an AB on both sides, I can subtract AB from both sides. And that leaves me with BC equals EF. And we got that from our subtraction property. And now my proof, this is what I have at the bottom of my proof, so now I know I am done. I proved that if this given information up here is true, then BC equals EF. Our next question asks us to prove that if M is the midpoint of Ln, then Ln equals 2 of Ln. So given that M is midpoint, of Ln, prove Ln equals 2 Ln. Okay, so I'm going to write our statements and reasons over here. Our first statement is always our given information. So we have M is midpoint. Of Ln. The reason we can write that is it is given. Our next thing that we are going to write is that if this is the midpoint M, we know that these two segments, LM and MN, are congruent because that is our definition of midpoint. Okay, so if LM equals MN, we also know that our whole line segment, LN, is equal to those two pieces added together. We have LM plus MN. And we know that because of our segment addition postulate. So if you are doing some of these proofs and you're getting stuck, go back to the reasons at the top of this page and use those reasons as hints. So if you can't figure out something to write down, look at that. So we're getting close here to what we want to prove. We want to prove that ln is equal to 2lm. So if we know that mn here is equal to lm, we can substitute that in. So if we have our next statement, ln is equal to lm, plus lm. And that is our substitution property. And then we know that ln is equal to lm when we combine like terms. And that is what we were looking for, so that is the answer to our proof. We are done with that one. So let's move to the next. Now we have an example with angles, so we're still doing the same thing. We have statements on the left and reasons on the right. Okay, so we're showing that if the measure of angle FAN equals the measure of angle PET and the measure of angle 2 equals the measure of angle 4, then the measure of angle 1 equals the measure of angle 4. Okay, so this first stuff is our given information, so I'm just going to write it straight over here. If we are saying that the measure of angle FAN equals the measure of angle PET, it's given, and the measure of angle 2 equals the measure of angle 3 is given. So let's look at that information on our diagram. So we know that FAN equals PET, this angle over here, and angle 2 is equal to angle 3. So the first thing I'm going to write is that the measure of angle FAN is equal to the measure of angle 1 plus the measure of angle 2. And I'm also going to write my other angle addition is PET, which is angle 3 plus angle 4. That is our angle addition postulate. For C, our next statement, we are going to write in some substitutions because we're trying to get measure of angle 1 and measure of angle 4 to equal each other. So I know that FAN and PET are the same, so I can substitute into our original equation at the top my values of angle 1 plus angle 2 and angle 3 plus angle 4. So I can say that measure of angle 1 plus measure of angle 2. So I'm taking this and substituting it in right here, and then taking this and substituting it in up here, equals 3 plus angle 4. Okay? And now once I have this, I am substituting. And I also know that measure of angle 2 is equal to the measure of angle 3. So I can take this right here and plug it in right here. Measure of angle 2 equals the measure of angle 3. So that way I have the measure of angle 3 on both sides. And I got there using substitution. So my final step here, I'm trying to get rid of those 3's. If I subtract the measure of angle 3 from both sides, I'm left with the measure of angle 1 is equal to the measure of angle 4. And that is what I wanted. So I got that from subtraction. And I am done with that proof. Our last one here says that show if angle 1 is complementary to angle 2 and angle 2 is complementary to angle 3, then the measure of angle 1 equals the measure of angle 3. So let's write up our two columns here. Statements and reasons. Always starting with my given information. So I know that angle 1 is complementary to angle 2, given. And then angle 2 is complementary to angle 3, which is given. So if angle 1 and 2 are complementary, that means angle 1 plus angle 2 is equal to 180. That's supplementary. It's equal to 90 degrees. That is our definition of complementary. And we also know that angle 2 plus angle 3 is equal to 90, which is our definition of complementary again. My next thing I'm going to do, if both of these equations are equal to 90, I'm going to substitute. I'm going to say if angle 1 plus angle 2 equals 90 and angle 2 plus angle 3 equals 90, then I can say angle 1 plus angle 2 is equal to angle 2 plus angle 3. Substitution. And then finally, if I subtract angle 2 from each side, I'm left with angle 1 is equal to angle 3 using my subtraction property. And that's what I was trying to prove, so I am done with that proof.